three examples I'm going to go through can be seen here. Function y is equal to 3x minus 2x squared by 5 plus 4x. The second will involve an exponential in product with an x, and the third will be using trigonometric functions, cosine and sine, and using the product rule to get the final differentiated result. This is a video tutorial that's going to go through how to use the product rule to differentiate a function. So the product rule is used to differentiate a function of the following form. It's used when you have one function that's in product, so it's being multiplied by a second function. So similar to that of the other differentiation methods, such as the quotient rule or the chain rule, each of them is used when the function y is of a particular form. So as mentioned, the product rule when you have two functions in product with one another. The quotient rule is used when you have a function that's divided by another function, and then for the chain rule you would use on composite functions, so when you have an inner and an outer function. So from that you can see when you have a function y, you can tell what method you need to use in order to differentiate it from analyzing how the function itself is composed. So I can see from this example, you have one function in product with another function, therefore I have to use the product rule to differentiate. I've written the product rule explicitly over here on the top right. So what it states is if you have a function f of x and a function g of x in product, the differentiated result of that is going to be the first function f of x. That's going to be multiplied by the second function differentiated, that's why we have the prime, and that is summed with that second function, which is multiplied by the first function differentiated. Over on the right hand side, I'm going to write out each constituent part. So I want to find what our f of x is. So here in our function y, our first function here is our f of x. And as we mentioned before, that's in product with a second function here, which is our g of x. So we have our f of x in product with our g of x. So first we're gonna write out each part explicitly. So our f of x we know to be 3x minus 2x squared. And we know that we're going to be using an f prime of x, so we'll just do that here. That's going to be equal, well, if we differentiate this, we know that 3x goes to 3, and we know that a minus 2x squared goes to minus 4x. Next we have our g of x. And we know our g of x is the second function that's in product, and that is a 5 plus 4x. And once again, we're going to be using g prime of x. So that differentiated, we know that constants go to 0, and our 4x will just give us back the number 4. Okay, so now that we have found values for both our f of x and g of x, and then functions differentiated, we're ready to form our final result for the product rule. So over here, I'm going to write dy dx. So remember, our function y, we want to differentiate this with respect to x using the product rule. Product rule is written up here, and we have each individual part written down here. So the first part of our product rule is our f of x. So we know that our f of x is 3x minus 2x squared. We can see that that's in product with g prime of x, which we found to be 4. And we know that's going to be summed with our g of x, which we know is 5 plus 4x. And that itself is in product with f prime of x, which we know is 3 minus 4x. So what we need to do now is all we need to do is simplify this equation. So following from here, if we multiply constant 4 into this first expression, we're going to get a 12x, and we're going to get minus 8x squared, and that is going to be summed with multiplying these two expressions out. We're going to have a 15, then we're going to have a minus 20x, then we're going to have a plus 12x, and we're going to have a minus 16x squared. Continuing down, so our x squared. Let's clean that up first. So minus 16 and a minus 8. That's going to be minus 24x squared. And then we have our x values, which we have a 12, we have a positive 12, so that's going to be 24 minus 20, it's going to be plus 4x, and we're left with our only constant is the 15. So our next example is we're dealing with function y, which is equal to x times e to the x. So if you would like to pause the video and give this a go yourself and then come back to see if you were successful or not. So the first thing that we're going to do is similar to what we did before in the first example, is we're going to write out what our f of x is and what our g of x is. So we can see that we have a function y that consists of a function x multiplied by another function e to the x. So that's why we know we're going to use a product rule, because we have one function in product with another. So once again, we're just going to write down the individual parts of the product rule over here. So our f of x is going to be this first function. So that's just going to be x. So our f prime of x, that's just going to be 1. And we know our second function, which is g of x, is going to equal e to the x. And we know that g prime x, so e to the x when differentiated is e to the x. Alright, so once again, all we're going to do now is form the final result for differentiating this function y. So that's going to be given by dy dx. And that is equal to our f of x is x. That's multiplied by g prime of x, which we know is e to the x. And that is summed with g of x, which is also e to the x. And that's in product with f prime of x. I'll just write this in just for completeness. Again, so all we're going to do is simplify. So this is going to equal to x e to the x plus e to the x. And you should be able to spot here that we have some common attributes with each expression in this equation. What we're going to do is we're going to take out that common factor. So that common factor is e to the x. And then that just leaves us with, well, what's the additional term in this expression? It's the x. And then if we take e of the x out of this expression, that will just leave us with a 1. So our final result then is, so we have our dy dx, and that is going to equal e to the x by x plus 1. So the third example here is we're going to be differentiating trigonometric functions, so it's going to be slightly different. What you need to try and determine is, looking at our function y, where does the product rule come into play? Does it come into play when we're differentiating 2 sine of x or 2x cosine of x? So trying to get into the habit of looking at separate functions and determining if they are of the correct form to use the product rule. So hopefully that you noticed the product rule can be used on this first expression here. And the reason for that is because we have 2 functions in product with one another. The first function is here, which is our 2 of x. That's our f of x. And then the second function is this cosine of x, which therefore will be our g of x. So because we have an f of x in product with a g of x, we're going to use the product rule. Now this one, can you see that we do not need the product rule because we do not have a function with respect to x multiplied by a second function with respect to x. All we have is one sine of x function here. This 2 is just a numeric constant, so we don't need to use the product rule in order to differentiate this expression. We'll be using the chain rule, which I have a previous video on. So getting into this example, we're going to write out our f of x here to be 2x, and then that differentiated we know is going to be 2, and then our g of x we know is cosine x, and our g prime of x, cosine differentiated, is minus sine of x. So we need to notice that we're going to use the product rule only on this first expression here. So it's going to be this section of y that we use the product rule, and in this second part here we're going to be using the chain rule to differentiate it. So how we're going to do this is we're just going to go straight in with our dy dx, and that's going to be equal to. So we need to differentiate this expression using the product rule. So the product rule is given over here. So that means our first component we need to write down is our f of x, which we have seen over here to be 2x. The second factor is g prime of x, which we have determined to be minus sine of x. So minus sine of x. That is summed with g of x, which we see here to be cosine of x, and that's in product with f prime of x, which is just a 2. And then we can't forget we have this second expression up here that we also have to differentiate. And we know that sine x differentiated goes to cosine x. So that's going to be a minus here. The 2 just stays where it is, and the sine of x changes to cosine of x. Right, so that's the function y differentiated. Just in case it's a little bit confusing, this was the product rule, this part here, and then this is here when we use the chain rule to differentiate the sine to go to cosine. So now it's a case of, as before, we're just going to tidy up this equation and then we're complete. So dy dx is equal to, we just move this negative sign to the front, so that's just going to give us a minus 2 of x sine x. And this here, we just move the 2 to the front by convention. That's going to be 2 cosine x. And then we can't simplify this anymore. So we're going to have 2 cosine x. And then that leaves us with a 2 cosine x minus 2 cosine of x. So they cross out with each other. And then that just leaves us finally with a minus 2x sine of x. That's our final result for the differentiation of function y with respect to x. Alright, that's the 3 examples done. I hope it made sense and you found it useful. If you did, if you could like and subscribe and maybe hit the notification bell to get the channel up and running, it'd be much appreciated. And yeah, hope you enjoyed it, and we'll see you in the next video.